Hello and welcome to this course, Virtual Routing and Forwarding, also known as VRF. My name is Mohammed Imani, and for the past 18 years, I have been teaching different networking technologies. In this course, I'm going to take a deep dive into virtual routing and forwarding, and I'm going to speak about the topics that I have listed here. You can see that. First of all, I'm going to start with the definition of VRF, what is VRF, and then I'm going to tell you that there are two different types of VRFs, as a matter of fact. The first one is the actual VRF that most of you expect to know about that, and the second one, of course, is called VRF Lite. VRF Lite, as a matter of fact, is a subset of VRF. It is not complete VRF, or some people call it VRF without MPLS, or without multi-protocol BGP. VRF Lite, of course, has some advantages and some disadvantages. I'm going to explore them, and I'm going to tell you where to use VRF. Most of the time, of course, it is inside data centers or small offices. And the next thing which I'm going to explore is to create VRF on different contexts. When I say different contexts, I mean normal iOS that most of you work with, iOS XR, also Nexus switches. These are kind of similar, but there are differences in syntax. Next, I'm going to speak about how to create VRF in these contexts, and creating VRF in the context of multi-protocol BGP plus VPN, of course. I'm not going to go through MPLS or BGP. They are, of course, separate courses on their own, and just speaking about them is going to require something more than 20 hours maybe. But here, my focus is going to be on VRF, so everything about VRF is going to be explored. And the next thing is limiting the number of routes in VRF routing table. Everybody wants to have multiple customers. So when you are an ISP, you want to have something like hundreds of customers, and each one of them is going to have a routing table for itself. But the routers, of course, are not going to be able to handle all of these routes. So what we need to do is to limit the number of routes in each VRF, and this is going to be mandated for all the customers as well. I'm going to speak about default management VRF. This one is interesting because on Nexus switches specifically, you might want to have some special modules, which are called management modules. These management modules have some Ethernet connections, and using them, you can easily connect to the switch with high speed instead of having a console port connection. I'm going to explore that as well. Then the interesting part, of course, is going to be here, route linking between different VRFs. This one is interesting. If you are actually doing merging, acquisition, or something like that, you might want to have routes from different routing tables, different VRFs actually in your VRF. And there is another situation in which, for example, your customers have their own VRFs and they reach their branches, but here they want to have something like an internet connection, which is in global routing table. And they are going to be able to do that using the technologies that we have in here. And I'm going to explain all of them to you. So this is pretty much everything about the topics, but there might be some more things which I'm going to talk about later as situation arises, of course. So that's it for the outline. So let's get started.
So let's continue what we started in the previous session. I showed you two key features of virtualization. Like I said, consolidation and isolations are very important features of virtualization, and almost every virtualization has these two features. And I showed you that we can virtualize a LAN and create VLAN. And when you create VLANs, it seems like you do not have one switch. It seems that one switch becomes multiple switches. Now these are not complete rectangles, but that's okay. You know what I mean. In VRF, what happens is this. You do not use just your physical router. One router looks like multiple routers. Now they do not really look like routers, but you know what I mean. Okay, so this is the concept that we have here. Now before continuing, let me talk about different types of VRFs. Of course, I'm not going to go deep into them right now. I'm going to, show you the complete configuration and everything about them in later sessions. But you should know that we have two types of VRFs. One is the actual VRF that everybody talks about. One is a VRF that nobody talks about so much, as a matter of fact. The actual VRF, which is called VRF, of course, uses labeling in layer 3, exactly like what you have in layer 2. When you have VLANs, you add some tags to that to make sure that you know this traffic belongs to which VLAN. And VRF uses labels, again, exactly the same as what we use tags in VLANs. The VRF is implemented in MPLS and multi-protocol BGP. So when you use VRF, as a matter of fact, you are talking about VRF with MPLS most of the time. In contrast, VRF Lite is kind of VRF without MPLS. So when you are talking about VRF Lite, you are talking about just one router most of the time, which is virtualized, and you do not really extend this. You can extend this to multiple routers, but you do not really go for that, because extending it to multiple routers is going to give you headache. So what you do is to just suffice to virtualize on one router. And most of the time you're talking about office LANs or small data centers. Or sometimes you just go with virtualization of security zones on just one router again. Like I said, I'm going to talk about this in depth. Let's go for some other slides and see what we have there. Here again, the concept of virtualization of a router is there. Like I said, it looks as if there are multiple routers and each one of them has its own routing table, which is very important to understand. We can have multiple routing tables, each one of them separate from the other one. They do not really know about each other unless we want to. And the next thing is we can use it with multiple protocols and even VPNs, which we are going to configure, and I'm going to show you what they are in a later session. So we have some key features like route distinguisher, which is very important to understand. What is a route distinguisher? Like I said, we can have multiple routing tables inside the router. So this is the first one, this is the second one. Let's say that the first one has a route of 10, 10, 10, 0/24. The second one can have a route of 10, 10, 10, 0/24. And I said in previous session that this is okay. Overlapping routes are okay. We can distinguish them from each other. How? By adding a route distinguisher. Let's say it is like a color. I'm going to add a tag in front of this. Let's say that this is for this routing table because it has a red label on that. And this one has a magenta label on that. I have colored the routes, so each one belongs to one of these routing tables. And route distinguisher does this, as a matter of fact. It is important on just the local router. When transferring the routes, route distinguisher doesn't do anything. But on a local router, it is very important to understand that this one is not going to be mixed with the other one. How can I do that? Like I say, I'm going to add a 64-bit value to the beginning of these routers. And this is going to be carried along with the route, but like I said, most of the time we call this local significant. It means that in transition, it doesn't do anything. We prepend it to the prefix and we send it to other routers so that they know that, again, this belongs to this specific routing table. Now, like I said, this is a 64-bit value. And what does this 64-bit value show us? We can, as a matter of fact, present it in different ways. There are three types of presentation. The first one, of course, says that what type of field we are talking about. So 2 bytes of this 8 bytes is going to be allocated to type field, but we are going to be left with 6 more bytes. Now this 6 more bytes can be used in 3 different ways. Like I said, we can have an AS number in the beginning and then assign a 4-byte sequence number to the end. This is type 0. We can have an IP address like raw derived, for example, in the beginning and then add a sequence number to the end. Or we can have an AS number in the beginning with 4 bytes, of course, and then a sequence number in the end. Now, this means that we can have something like 10, 10, 10, 1, then a colon here, then, for example, 272. This is one type of, notation, which is type 1, as a matter of fact. You see, this is IP address, and then the sequence number after that. But who does this? As a matter of fact, this is a very hard way to show this. What I really need to is some simpler way so that I can see that and I understand it easier. So most of the time what I do is to use 2 numbers. So the last notation is the one that most of network administrators or network experts go with. A number here, a colon, and another number here, like 1, 1, right? Now it doesn't really matter what number you are going to use here, but what is important is you can just distinguish this from another one. Now we add this to the beginning of the prefix which we are going to install in our routing information base. So I have 1, 1 in the beginning, and then let's say that 10, 10, 10, 0/24. Now this is the color one, right? Based on this, I can tell this belongs to the first routing table. If I have something like, for example, 3101, then 10, 10, 10, 0/24, I can say this second one has another route distinguisher, so they are not going to be mixed. Each one of them is going to go into one routing table. So this is what route distinguisher is. But there is another concept which a lot of people mix with route distinguisher. Like I said, route distinguisher is locally significant, but route target is significant in transit, which is very important to understand. The format of route target is kind of similar to route distinguisher, but what route target does is this. I'm going to have this router here connected to another router here. Now this is going to have this routing table, and for this specific VRF, a routing table on the other side, which need to be in sync, right? This is what routing means. Now I want to make sure that anything from this is going to be installed in this and vice versa. So what should I do? I say when I am sending this to the other side, I say that I am exporting this with a specific value like 1, 1. This is going to say I am importing just routes that have 1, 1, not the route distinguisher. This is an extra value, like I said. So this is going to say I'm exporting with 1, 1, and other side says, okay, you exported this with 1, 1, so anything that comes with 1, 1, I'm going to install it in here. And it says I am exporting everything with, let's say, 2, 2. This means that the other side needs to make sure that anything with 2, 2 is going to be imported. Do they have to be different? No, of course. I can say I'm exporting with 1.1, the other one is going to receive 1.1, and the other side says, okay, I am exporting with 1.1. It doesn't have anything to do with the importing, of course. But like I said, I just separated the values so that you can understand easier. So again, they are, assigned to the values, to the routes, so that the other side knows which one is going to be imported in one of these. Now, can I import one of these into multiple routing table on the other side? It is possible. Let's say that I have another routing table here, and for some reason, anything from that side that comes from the other side with a route target of 1.1 needs to be imported here as well. So I can do that. I can say I am importing 1.1 as well. So this is possible. There are scenarios which we are going to cover and tell you what are the situations in which we do this, but right now we are going to just go with this. So let's continue what we started in the previous session. I showed you two key features of virtualization. Like I said, consolidation and isolations are very important features of virtualization, and almost every virtualization has these two features. And I showed you that we can virtualize a LAN and create VLAN. And when you create VLANs, it seems like you do not have one switch. It seems that one switch becomes multiple switches. Now these are not complete rectangles, but that's okay. You know what I mean. In VRF, what happens is this. You do not use just your physical router. One router looks like multiple routers. Now they do not really look like routers, but you know what I mean. Okay, so this is the concept that we have here. Now before continuing, let me talk about different types of VRFs. Of course, I'm not going to go deep into them right now. I'm going to show you the complete configuration and everything about them in later sessions, but you should know that we have two types of VRFs. One is the actual VRF that everybody talks about. One is a VRF that nobody talks about so much, as a matter of fact. The actual VRF, which is called VRF, of course, uses labeling in layer 3, exactly like what you have in layer 2. When you have VLANs, you add some tags to that to make sure that you know this traffic belongs to which VLAN. And VRF uses labels, again, exactly the same as what we use tags in VLANs. The VRF is implemented in MPLS and multi-protocol BGP. So when you use VRF, as a matter of fact, you are talking about VRF with MPLS most of the time. In contrast, VRF Lite is kind of VRF without MPLS. So when you are talking about VRF Lite, you are talking about just one router most of the time, which is virtualized, and you do not really extend this. You can extend this to multiple routers, but you do not really go for that, because extending it to multiple routers is going to give you headache. So what you do is to just suffice to virtualize on one router. And most of the time you're talking about office LANs or small data centers, or sometimes you just go with virtualization of security zones on just one router again. Like I said, I'm going to talk about this in depth. Let's go for some other slides and see what we have there. Here again, the concept of virtualization of a router is there. Like I said, it looks as if there are multiple routers, and each one of them has its own routing table, which is very important to understand. We can have multiple routing tables, each one of them separate from the other one. They do not really know about each other unless we want to. And the next thing is we can use it with multiple protocols and even VPNs, which we are going to configure. And I'm going to show you what they are in a later session. So we have some key features like route distinguisher, which is very important to understand. What is a route distinguisher? Like I said, we can have multiple routing tables inside the router. So this is the first one, this is the second one. Let's say that the first one has a route of 10, 10, 10, 0/24. The second one can have a route of 10, 10, 10, 0/24. And I said in previous session that this is okay. Overlapping routes are okay. We can distinguish them from each other. How? By adding a route distinguisher. Let's say it is like a color. I'm going to add a tag in front of this. Let's say that this is for this routing table because it has a red label on that. And this one has a magenta label on that. I have colored the routes, so each one belongs to one of these routing tables. And route distinguisher does this, as a matter of fact. It is important on just the local router. When transferring the routes, route distinguisher doesn't do anything. But on a local router, it is very important to understand that this one is not going to be mixed with the other one. How can I do that? Like I say, I'm going to add a 64-bit value to the beginning of these routers. And this is going to be carried along with the route, but like I said, most of the time we call this local significant. It means that in transition, it doesn't do anything. We prepend it to the prefix, and we send it to other routers so that they know that, again, this belongs to this specific routing table. Now, like I said, this is a 64-bit value. And what does this 64-bit value show us? We can, as a matter of fact, present it in different ways. There are 3 types of presentation. The first one, of course, says that what type of field we are talking about. So 2 bytes of this, 8 bytes is going to be allocated to type field, but we are going to be left with 6 more bytes. Now, this 6 more bytes can be used in 3 different ways. Like I said, we can have an AS number in the beginning and then assign a 4-byte sequence number to the end. This is type 0. We can have an IP address like router ID, for example, in the beginning and then add a sequence number to the end. Or we can have an AS number in the beginning with 4 bytes, of course, and then a sequence number in the end. Now, this means that we can have something like 10, 10, 10, 1, then a colon here, then, for example, 272. This is one type of, notation, which is type 1, as a matter of fact. You see, this is IP address and then the sequence number after that. But who does this? As a matter of fact, this is a very hard way to show this. What I really need to is some simpler way so that I can see that and I understand it easier. So most of the time what I do is to use 2 numbers. So the last notation is the one that most of network administrators or network experts go with. A number here, a colon, and another number here, like 1, 1, right? Now, it doesn't really matter what number you are going to use here, but what is important is you can just distinguish this from another one. Now, we add this to the beginning of the prefix which we are going to install in our routing information base. So I have 1, 1 in the beginning, and then let's say that 10, 10, 10, 0/24. Now, this is the color one, right? Based on this, I can tell this belongs to the first routing table. If I have something like, for example, 3101, then 10, 10, 10.0/24, I can say the second one has another route distinguisher, so they are not going to be mixed. Each one of them is going to go into one routing table. So this is what route distinguisher is. But there is another concept which a lot of people mix with route distinguisher. Like I said, route distinguisher is locally significant, but route target is significant in transit, which is very important to understand. The format of route target is kind of similar to route distinguisher, but what route target does is this. I'm going to have this router here connected to another router here. Now this is going to have this routing table, and for this specific VRF, a routing table on the other side, which need to be in sync, right? This is what routing means. Now I want to make sure that anything from this is going to be installed in this and vice versa. So what should I do? I say when I am sending this to the other side, I say that I am exporting this with a specific value like 1, 1. This is going to say I am importing just routes that have 1, 1, not the route distinguisher. This is an extra value, like I said. So this is going to say I'm exporting with 1, 1, and other side says, okay, you exported this with 1, 1, so anything that comes with 1, 1, I'm going to install it in here. And it says I am exporting everything with, let's say, 2, 2. This means that the other side needs to make sure that anything with 2, 2 is going to be imported. Do they have to be different? No, of course. I can say I'm exporting with 1, 1, the other one is going to receive 1, 1, and the other side says, okay, I am exporting with 1, 1. It doesn't have anything to do with the importing, of course. But like I said, I just separated the values so that you can understand easier. So again, they are, assigned to the values, to the routes, so that the other side knows which one is going to be imported in one of these. Now, can I import one of these into multiple routing table on the other side? It is possible. Let's say that I have another routing table here, and for some reason, anything from that side that comes from the other side with a route target of 1, 1 needs to be imported here as well. So I can do that. I can say I am importing 1, 1 as well. So this is possible. There are scenarios which we are going to cover and tell you what are the situations in which we do this. But right now, we are going to just go with this. So let's start the configuration. What I'm going to do here is to show you the actual configuration without VRF and what happens if we do not configure VRF. And then I'm going to assign VRFs here. And I'm going to say that I have 2 parts in my network. One part is here, the other part is here, and they should not be able to talk to each other, even if they have overlapping IP addresses. So let's go with this configuration. I'm going to start without VRF and show what the result is. So let's go to router 1. I'm going to show CDP neighbor. The IP addresses are not configured, and I'm going to do this right now. IP address is going to be for interface Ethernet 0, 0. IP address, of course, is going to be 10.1.2.1, 255.255.255.0. For interface Ethernet 0/1, that's going to be 131. For 2, that's going to be 151. And for 3, that's going to be 141. And let's have a loopback interface as well. Of course, I'm not going to have anything to do with that, but let's say that I'm going to have 1111 255 255 255.0 as the IP address here. And I'm going to have a routing protocol here. So let's go with OSPF, okay? Or EIGRP, doesn't matter which one. So I'm going to type rather, let's say OSPF 1. Router ID is going to be 1111. And the networks that I have is going to be 10.121.0.0.0.0. All of them are going to be in area 0. So this is the first one. This is the next one. Next one. Next one. And finally, I'm going to have 1111 in my OSPF instance. So let's do this. Let's go to router 2, enable, show CDP neighbor, and you can see that R1 is connected to Ethernet 00. So let's go to configuration mode, interface Ethernet 00. IP address is going to be 10.122. And let's have a loopback interface as well. Interface loopback 0. IP address is going to be 2222. Too many 5s and too few 5s. And no 2, of course. Okay. Now I'm going to have router OSPF 1 as well. So router ID is going to be 2222. And the networks which I'm going to add 10.122 in area 0. Now you can see there is an adjacency after some time. Also the network 2222 0000 area 0. And here is the adjacency that I have here. Okay, let's save everything, go to router 3, and I'm going to be super quick. In configuration, and shows CDP neighbor says that Ethernet 00 is connected to router 1. So interface Ethernet 00, IP address is going to be 10.133, and an interface loopback of course should be there. IP address is going to be 3333. Okay, now router OSPF 1, and the router ID going to be 3333, network 133. Okay, and also network 3333, and you see the adjacency of course. To the configuration on other routers as well. IP address is going to be 10.144, and too many D's. Interface loopback 0. IP address is going to be 4444. And again, router OSPF 1. Router ID is going to be 4444. Network 4444. In area 0. Network 10.144. In area 0. Okay, after some time we should see an adjacency as well here. And let's go and do the last one. In configuration mode, router, okay, interface Ethernet 00, IP address is going to be 10.155, and interface loopback 0 is going to have an IP address of 5555. Okay, and finally OSPF process. And the networks, of course. And we should see an adjacency here. Okay, so this is the basic configuration that we have right now. So if I check the IP routing table, and what I am checking here is called the global routing table. You can see that I have access to almost every other router in the network. So whether they are branches of my company or not, it doesn't really matter. I have access to all of them. Now I'm going to assign these as some other networks attached to this, and there is going to be the problem. And of course the first problem is I shouldn't be accessing routes from another customer's routing table. That's a problem. I should not be able to do that. So let's go with some configuration, some VRF configuration, and see what we are going to have here. So on router 1, which is the center, I should kind of virtualize the routers. So for this I need to configure VRFs, and there are two ways to configure VRFs. One the old school, one the new way. So for old school, what you need to do is to type IP VRF, and after that a name, let's say for example red, and as soon as you hit enter, there are some more commands that you can configure here. Most important of them is route distinguisher and route target. So let's start with route distinguisher. So we know that router 2 and 4 need to be able to, communicate with each other, but not the rest. So what I'm going to do is to type 24, for example, 24. You know the syntax of route distinguisher, but I'm going with simple numbers so that I can remember it easier. So this is my route distinguisher. Everything which is going to be prepended to the routes so that I know which routing table this route belongs to. So once again, which routing table this route belongs to. This is going to be determined by the route distinguisher. What about route target? If I type route target, you can see that I can assign export and import separately, or I can assign both the same. So what does this mean? Let's say that I have this on one router and this on one router, routing tables. Now I want to synchronize these two. This is going to send to the other side routes with a route target of, let's say, 1, 1. When it sends with 1, 1, if the other side wants these routes, it needs to import 1, 1. So this is 1, 1 here. Now the same way back should be implemented. Now again, I can use the same values because they do not have anything to do with them, or I can just assign new values, for example 2, 2. And this side should be able to receive 2, 2 as well. But just for the sake of simplicity, again, I'm going to go with similar numbers on both sides. So if I just type both, it is going to create two commands for me. Both is not a command, it's a micro, which means that if you type both, it is going to create an import and an export. So what I'm going to do is to type both, and let's say that 24, 24 again for the sake of simplicity, because route target is a separate value, route distinguisher is a separate value, so they are not going to have any problem with each other if they are configured similarly. Very nice. Now that I have created the VRF, if I just show IP VRF here, or show VRF simply, both of them are going to show you the same result. You can see that it says there is a VRF red, and the route distinguisher is 2424, and it hasn't been assigned to any interface. The difference between show IP VRF and show VRF is this part. Show VRF is going to show you the protocol which is enabled for this. And if I go up here, you can see that show IP VRF does not have any address family inside. So this means that we are kind of limited when we use IP VRF for configuration of VRF. Now let's go and assign this to the interfaces, because it says that we haven't assigned an interface to this VRF. So what I need to do is, first of all, check to see what IP addresses I have. I don't want to forget what IP addresses I have. So either I have the diagram, and based on that diagram I'm going to know which IP address is assigned to which interface, or I just have show IP interface brief here. Now that I have here, and you know why I did in a second. So I'm going to go to configuration mode and I go to interface Ethernet 00, which I believe is connected to router 2, yes. Then I'm going to type IP VRF, and that is because I created this VRF using IP VRF. And then forwarding, and then the name of the VRF that I have here. Now see what happens. If I hit enter, it says that the IP address that you had assigned before is now removed. You need to assign a new IP address. Okay, interesting. Now let's go here and type IP address again. IP address is 10.1.2.1.255.255.255.0. Now I have this IP address connected here, and I'm going to go to privilege mode. I'm going to show VRF one more time. Now it says that interface Ethernet 00 is connected to, is kind of assigned to VRF red. Very nice. Let's save everything and do some verification. From router 2, I can ping 10.1.2.1, and the ping is successful. From router 1, I cannot ping. That is interesting, right? Why can't I ping from router 1 while the ping from router 2 was successful? That is because this address, this interface, is assigned to a VRF, so normal VRF ping is not going to work. So from now on, you should know that any command that we have has a global version and has a virtual version. And for virtual version, what I need to do is to type ping, and after that I use the VRF, which is going to be here. So ping VRF red 10.1.2.2. Now this is going to work without any problem. Or 10.1.2.2 as a matter of fact. I just type 1.1.2.2. So let's do this one more time. Instead of 1, I just hit 10, and you can see that the ping is super successful without any problem. Okay, let's do the rest of the configuration in next session. Okay, continuing the configuration. So far we have assigned Ethernet 00 to VRF red, which means that this is on another virtual routing table. We didn't touch the customer router because customer router doesn't need to know anything about this VRF configuration. It is just connecting to the router, and it says it as a physical router. It doesn't understand whether this is virtual or physical. So let's go to router 1. So this is the one that we are going to configure, and Ethernet 03 is going to be part of VRF red. And after that, I need to make sure that they have connection. So let's go here, show run interface Ethernet 0/3 says so far I have only one IP address configured for that. So let's go to here, interface Ethernet 0/3 is going to be under VRF forwarding table red. And I hit enter, and again you see that it loses the IP configuration, and this is why I just showed the running configuration so that I can easily copy that and paste it here, and now everything seems to be good. And again, if I want to ping now, because I am putting this inside a VRF, I need to use the VRF to ping. So I ping, but VRF is going to be red, and this is case sensitive. Make sure that you type it If it is all capital, you type it in all capital, or whatever case that you have used, you need to use that. And that is going to be 10.144. And you can see that the ping is successful without any problem. It runs and everything seems to be good. Now, what about these two routers? Are they able to ping each other? As a matter of fact, there is a problem here. If I just go to router 4, let's go to here, you can see that now the adjacency is lost. We do not have a neighborhood. Why? Because now this interface is not part of the interface that was used to be in global configuration mode, in global routing table. So if I just show IP route connected, I cannot see that interface here. 10.1.4 is not part of this, but it is part of a VRF. So show IP route VRF red connected shows this as part of that, which means that now OSPF process needs to understand this. Interestingly, there is such thing possible. And again, all the configuration go to router 1 because other customers do not really need to know anything about VRF. VRF should go to router 1. So I just go to router 1, and what I'm going to do is to remove the lines from router OSPF. So show run section router OSPF. So they are already removed automatically, but if they are not, you can really remove those lines from here. 10.1.2.1 and 10.1.4.1, those are the networks that no longer need to be under OSPF process. So what I need to do is to create a new process. Process 1 is already taken, so I'm going to go with process 2, OSPF process 2. And now, because this is going to go for a VRF, so what I need to do is to assign the VRF here. So I just type VRF, and the name of the VRF is red. Okay, now that I have this, I can assign a router ID, of course, of 1111. There is no problem with that. It says router ID is in use by OSPF process 1. Okay, doesn't really matter. Let's say that 11.11.11.11. It doesn't have to be one of the interfaces. It just has to be, unique here. Now let's add the networks here. So what I'm going to do is to type network 10.1.2.1 that belongs to area 0, and after some time you see this loads, and also 10.1.4.1, and there should be no problem here. Very nice. Now if I go to router 2, I should see it show IP route, and there is no VRF on router 2, you know that. I should be able to reach to the other side. There is no problem with that. Now there are two networks which I'm going to add here. One of them 150.20.20.0 to router 2. So let's go to router 2. And I'm going to type interface loopback, for example, 20. IP address is going to be 150.20.22. And I'm going to go to router OSPF process, what was that, 1. And I'm going to add this network to the list of networks which are going to be advertised to the other side. And the same should go on router 4. On router 4 I have an extra network which is 150.44.4. So let's create this one. In configure terminal interface loopback 44. IP address is going to be 150.44.4.4. And router OSPF should advertise this. So 150.40.4.4 in area 0. Very nice. Now if I check this on router 2, I should see this network as well. So again, show IP route, it says that I can receive this from the other side and there is no problem reaching to that. So why is this in 60? Okay, that's right. This is the correct thing. So if I just go with a normal ping 150.20.22, you can see that it is reachable. So far what we have done is configured OSPF. Let me show this clearly. Show run section rather OSPF. Now you can see that there are two OSPF processes here. One, the global process without any VRF assigned. One, the VRF one, the virtualized one, which has its own routing table. So here, if on this router I want to check the routing table, I need to go with VRF. So show IP route is going to show me the global routing table, but show IP route VRF is going to show me the VRF routing table. For example, VRF red, as a matter of fact. And if you just type VRF all, you can see that all the VRFs, all the routing tables are going to be visible here. Global routing table plus the VRF routing tables here. And one of the routing table VRFs, of course, doesn't have anything. That is VRF blue, which we haven't configured yet. Okay, let's go for the configuration of the other VRFs. So let's exit here. And for this, I'm going to go with the new syntax, VRF definition. Again, you need to go to global configuration mode, type VRF, and instead of typing IP VRF, I just type VRF and go with definition, and then the name of the VRF here. Okay, now you see there is a small difference here, that is the address family. And this is necessary to be configured because we want to have this for IPv4 or IPv6 address family enabled. So what I need to do is to first of all configure an RD. So RD is going to be 3535. I can configure route targets. In my case, of course, this is not so necessary, but I can do that. Again, route target has the same syntax as the normal IPVRF command. I'm going to go with both, type 3535 as well here. Now I need to enable this for IPv4 address family, because if I just show VRF, you can see that VRF blue does not have any protocol enabled by default, although VRF red, which normal IPVRF command created, that has this IPv4 enabled. So what I need to do is to type address family IPv4 unicast and hit enter. And again, if I check this verification command one more time, now you can see that this protocol is added for VRF blue. This is one of the differences that you need to take care of. What about the other difference? So the other difference is when you assign it to an interface. Let's check the interface that we are going to assign to this. Interface Ethernet 01 and 02. So what I need to do first of all is to check the IP address on that. I show run for interface Ethernet 0/1, also 0/2. Now you see the IP address allocations to this. So what I'm going to do is to type interface range. I'm going to do both at the same time, Ethernet 0/1 to 2. Now, instead of typing IPVRF forwarding, what I need to type is VRF forwarding. So this is the difference. And after that, you just type the name. You just type the name, and it is case sensitive, of course, and you hit enter. Now it says that 2 IP addresses are lost. That's okay. I'm going to go with interface configuration mode. This is for Ethernet 01. So this was 02 and this was 01. So this is this, and 02, which is this one. Okay, now something interesting happens again. If I just show IP route, they are removed from the global routing table. Now they should be in their special VRF. So if I just show IP route VRF blue, you can see them here. Very nice. What about the OSPF process? Again, we need to take care of that. So if I just show run section rather OSPF, this is the configuration for global OSPF that we have. We no longer need these here. What I need to do is to remove them and assign them to an OSPF process that has a VRF enabled. So I just type rather OSPF 1. These two should be removed. I don't need them anymore. Also this one. I'm going to create a new router process, rather OSPF, this time 3 I guess, because 1 and 2 are used before. VRF blue. And let's say that the router ID is going to be something like 111, 111, 111, 111. And now the networks. These 3 networks should go here. Now after some time, you should see the adjacencies enabled without any problem. And there they are. Very nice. Now again, if I show IP route VRF blue, you see the routes here. For router 3 and router 5, everything should be seamless. So if I go to router 5 and show IP route, I can see everything on the other side, and there is no problem with that. So let's enable these new networks that I am going to add. On router 3, I need to have 150.20.20.0 again. So I just go to router 3, enable interface loopback 0, or loopback 20, sorry. IP address is going to be 150.20.20, let's say 3. Of course, there should be a dot here. And if I go to router OSPF 1, I can advertise this as well. So 120.23 under area 0. And on router 5, I needed to add an extra one, 150.111.5.5. So here I just add interface loopback 111. IP address is going to be 150.111.5.5, and I need to add it to OSPF process. Rather OSPF 1 network is going to be this, and this is the wildcard mask, and this is the area. And save everything. Let's save everything. And save all routers. Now let's go to the diagram. Something interesting is here. You can see that I have 2 overlapping networks. This one is 150.20.20 network on red, 150.20.20 network on blue. All of them go through router 1, but they do not mix up. Each one of them is separate. As a matter of fact, this one just belongs to its own network. This one belongs to its own network, and there is no problem in routing for both networks. They are not going to mix up. None of the routers on the left are going to be able to get to the routers on the right because they are separate VRFs, and this is very, very important. Okay, so far so good. The overall configuration of VRF is done. You saw how we did that. We created VRF Lite. Everything was like this, nothing more than that. And also I showed you how you can configure the routing protocol to check this. Of course, I'm going to show you how we can redistribute if necessary, and how we can configure other routing protocols as well. But this is for VRF Lite, and in next session I'm going to use another topology to continue. Now I have added some extra area here. This represents the internet, and let's say that I have two customers, customer red and customer blue. Rather one is me, the ISP. And what I need to do is to make sure that these customer branches can connect to each other, which so far we have achieved this goal. But now they want to connect to the internet through me. So this is going to represent the internet. So let's do this. What I need to do before this is to have some planning. So let's say that here on blue we have a route target for import and for export, right? This is what we have. Route target for import was 35, 35. Route target for export was 35, 35. Now, because I want to get routes from the internet, what I need to do is to make sure that everything here, whatever the route target is going to be imported into my VRF. So let's say that this is 6, 6. What I need to do is to import 6, 6 so that I have knowledge about the internet prefixes here. So I'm going to have an extra route target import of 6, 6. Now, you know that when you want to receive from the other side some packets or whatever, when you want to communicate with some part of the network, you need to know about that part of the network, and that part of the network needs to know about you. So what I need to do is to send my route targets to here. But the problem would be if there is other customer here, which there is of course, they would receive my routes as well. I don't really want to do this. What I need to do is to have an extra route target for exporting, and that's going to be super different from what I have here. So I'm going to export with, let's say, 350, 350. This way, this is going to receive my routes as 350, 350. So that would be okay. It is not going to send my routes to this side. Now, what about this one? We had a route target import of 24, 24. Also a route target export of 24, 24. We need to import 6, 6. So route target import of 6, 6. And we need to export with something other than 24. So let's say that I'm going to have an export of 240, 240. Now, what about this green? Green is going to have import and export of 6, 6. Also, it is going to import 240, 240. Also, it's going to import 350, 350. That is what we need to do. There is an extra step that we need to take that is going to be on router 1. That is going to be the redistribution between different protocols, because normally they do not see each other. What I need to do is to make sure that redistribution is going to happen. Okay, the internet is going to be available using BGP. So I'm going to enable BGP on this interface between the internet and router 1. So let's do the configuration. And again, most of the configuration is going to be done on router 1. So let's go back to router 1. So far, I have OSPFs. What I'm going to do is to go for router BGP, let's say 16. Now I can have a BGP router ID and everything about that, but what I really need to do here is to make sure that, first of all, there is a VPN, and that VPN is going to be used here. That's VRF as a matter of fact, not VPN. So let's create a VRF before continuing with the BGP. So I'm going to type VRF definition is going to be green. Now VRF definition green is going to have an RD of 6, 6. Also route target for both is going to be 6, 6. And as I told you, it is going to import something from each one of those other VRFs. So I'm going to have a route target of import 350, 350, also 240, 240. Right? This is for green. What about IP VRF red? This is going to have a route target import of 6, 6, which is green. This is going to receive everything from 6, 6. It is going to export, but not as 24, 24. It is going to export as 250. So it's going to have export of 240 as a matter of fact, not 50. And finally we have VRF definition blue. The same thing should happen here. Route target import of 6, 6. And route target export of 350, 350. Okay, VRF definitions are done. Let's check the VRF definitions first of all. Show run section VRF. And you can see that I have imported and exported the correct things. Also, I can of course have this to show VRF detail. And when you do that, each one of the VRFs are going to be presented with all the details. What are the imports, what are the exports, and everything about that is going to be visible here. So let's say that, for example, I want to go with VRF name green. And that's going to show everything about green. It says that the route target 66 is imported. Also 350, 350, also 240, 240. These are for imports. 66 is for export. Very nice. There is no problem here. Now let's go back to BGP configuration. So rather BGP 16. And what I'm going to do is to have an IP, address family IPv4. And we have VRF green, because this is going to be under VRF green, right? And then I need to find the neighbor. The neighbor is going to be, let's say, 6666. I need to have an eBGP multi-hop as a matter of fact, because I am using the other side's loopback interface, but let's say that's okay. Or we can use the physical interface so that we do not really go with eBGP multi-hop. So 166, that is going to be my neighbor, which is going to be in remote AS 16. And that is the configuration so far. Now let's do the VRF configuration under the interface, which is connected to router 6. So if I show IP interfaces brief, the interface is Ethernet 1.0. So I need to go to interface Ethernet 1.0. That's going to be under VRF forwarding green. And then I need to have IP address assigned to that if this is not, removed. So IP address is going to be 10.161 again, 255.255.255.0. And that is the configuration that I need to do here for now. Let's go to router 6 and create the instance of BGP that we need here. Show IP interfaces brief shows us that these are the interfaces here. I need to go to here and type router BGP 16. I do not really need to go under any address family or something. What I need to do is to just type address of 10.161, which is in remote AS 16. And after some time I should see the BGP neighborship come up, which did. Now I need to go to router BGP 16. Now I need to kind of redistribute everything into global BGP and from global BGP into them back. So what I need to do is this. I need to type address family IPv4, and the VRF is going to be, what is the VRF? That was red. Under red, I'm going to redistribute OSPF2 because this is OSPF2, right? Let me make sure. Section rather OSPF says that yes, red is 2, blue is 3. Now I need to do the same thing here. Blue, and then OSPF3. Now that I have done this, I can just redistribute everything back to OSPF from BGP. So if I just go to rather OSPF2 VRF red, I can just type redistribute BGP 16 and then subnets. That's enough. I can of course go with VRF. I can just type VRF, for example, green BGP 16 here. But it says that inter-VRF redistribution is not allowed from BGP. That is why we need to go with that one. Now if I just try to see whether VRF red has received 100, 100, 100, 100, what I need to do is to go to one of the routers here, enable, and show IP route here. And now you see that 100, 100, 100, 100 is here very nicely. What about router 6? If I just try show IP routes, I can see that I am receiving routes from BGP from the other side. So let's go to here, router 1, and I need to go show run section router BGP to see what I have done so far. I have redistributed here. I have redistributed everything into this. OSPF, of course, with data redistribution from this. And I need to do the same thing for VRF blue. Show run section rather OSPF says that under red we have done this, but under blue we haven't. So I just go to here and I do the same thing here. And now everything should be just fine. We have done almost everything. If I go to router 6 and try show IP route, I have routes from different parts of the network. If I just go to router 2 and try show IP routes, I have routes from the internet only. This is that. And from my side, not from the other side. I don't see, for example, 5555. And if I go to router 3 and do this show IP route, you can see again that I have access to the internet. I see routes from my side, but I don't see routes from the other side. So this is how you do that. Okay, a recap of what we did. We just configured different route targets, made sure that when we are exporting to some third party like the internet here, we do not really send using our own route target. We define a new route target. And then we made sure that there is kind of a redistribution enabled here, most likely into BGP, because inter-VRF OSPF redistribution is kind of, quirky as a matter of fact. And you cannot really do that. It is a little hard to do. And this is what we really needed to do. And the configuration, let's check the configuration one more time. Show run section rather BGP was the last configuration that we did. Section rather, oh, that is router 3. Why did I go to router 3? That's fun. Here, what we had is redistribution into BGP, and then from BGP into those OSPF instances that we had. And this is going to conclude VRF Lite configuration, although some part of the configuration that I did is quite similar to what we are supposed to do on normal VRF, and you can see that later I will go with some more advanced configuration for VRF. So you can see that I have changed the topology a little bit, and I have added an extra router here, router 7. And per your vision, router 7 is not in any VRF. It has only the global routing table. I'm going to show you the configuration so far, the configuration that I have created between router 7 and router 1. And then what I'm going to do is to make sure that router 7 is able to reach to 100, 100, 100, 100. So what you need, as a matter of fact, is to make sure that some of the routes, or in my case, in this specific route, can be leaked into the global routing table and then advertised to router 7. So going to router 1, what I'm going to do is to show IP protocol. You can see that I have EIGRP1 set here. EIGRP1 is the protocol between router 1 and router 7, and it doesn't have any VRF set on that. So if I just want to show the running section of section router EIGRP, you can see that I have added the loopback interface, also the network between router 1 and router 7 to this, and show IP EIGRP neighbor says that I am neighbor with router 7. And also one more thing that I have set here is in the interface between router 1 and router 7. So if I show running section of interface Ethernet 1.1, you can see that I have set a summary address EIGRP between router 1 and router 7, and I have set almost everything to be sent to router 1. So this is going to be the one which I am sending to router 7. So if I go to router 7 and show again IP route, now you can see that this route, the summary address, has been received here. Also, I have some things here. For example, let's see. I need to see router 1's this network 1111 in router 7, but because we have the summary address here, it is kind of suppressed, but we can still ping it. So if I just try to ping 1111, you can see that the ping is quite successful. Now what I need to do is to configure route leaking. So let's start by doing the first thing. What I need to do is to create a policy-based routing, and this policy-based routing is going to be applied to this interface between router 1 and router 7. Ethernet 1.1 on router 1 is going to receive a policy-based routing. In this policy-based routing, I'm going to set everything that goes to 100, 100, 100, 100 to be set in VRF. And I'm going to give this interface's IP address as the next hop. So everything that goes through router 1 from there to router 6 is going to be changed into VRF. Then it is going to be sent to this interface, and this interface is going to, set the next destination for that. So you can see that we need a policy-based routing here, a route map which I'm going to create right now. This route map is going to have an access list, and in this access list I'm going to set any to any. It doesn't really matter what, but you can be more specific and say just one of the networks, for example, is able to do that. But I'm going to set this to any, and then send it there. Also, one more command which I need on Ethernet 1.1 is IPVRF receive, because I just want to make sure that things from VRF green can be received on this interface. Okay, let's start the configuration. For this, what I'm going to do again is to go to router 1, and let's clear the screen first of all. On router 1, I'm going to create an access list. So I'm going to create access list, let's say 100, and I'm going to permit IP any. Like I said, I'm not going to be so specific. Of course, I need to go to configuration mode and then create this command. Okay, Now that I have created this access list, let's create a route map. I'm going to create a route map. Route map is VRF to underline global. So this is going to have a permit, and I'm going to match it with access list. You just type match IP address, and the access list is 100. And what I need to do is to set the next hop. But here, because we are using a VRF on the other side, I need to type IP VRF. And then the name of the VRF is green, and then the next hop. The next hop is 10166. And hit enter. This is the route map that I am going to have. So the next phase is to go to interface Ethernet 1.1. Now that I am here, first of all, I need to set the policy map, IP policy, and we are using a route map. The route map name is VRF to global, so I just paste it here. Also, like I said, I need to receive the VRF, so I'm going to set IP VRF receive, and the name of the VRF which I am receiving from is green. So this is the interface configuration on router 1. So almost everything is done here. What I need to do is to go to router 6. Because router 6 doesn't know the way back to router 7, I need to add a static IP route. As a matter of fact, this is going to be set on router 6. So on router 6, what I'm going to do is to type en conft, and then I'm going to set a route back to 10170, which belongs to router 7, 255, 255, 255.0, and I need to send it back to 10161. This is the network which router 6 is connected to. So I hit enter, and almost everything should be done. Now what I need to do is to check my configuration. Can I ping from router 7 to 100, 100, 100, 100? If I just go to router 7 and try to ping 100, 100, 100, 100, now you can see that the ping is successful and everything seems to be fine. Of course, router 7 is not going to receive any route because it has this. Router 1's global routing table seems like this. And there is nothing here, but everything is done using policy-based routing. So this is how you leak routes between different VRFs or from VRF to global. So the next topology that I am using is a full MPLS topology, but I'm not going to go deep into MPLS. What I'm going to do is to just configure basic MPLS here. What is important for us in this course is the VRF configuration on provider edges. So I'm going to configure this, and what we need to know is our customers connect to us with different protocols. Like ISP, of course, can mandate the customer to use a specific protocol, but we can be resilient and we can say to the customers that whatever protocol you have, I'm going to support it as long as it is a standard or it meets our requirements, so that's not going to be any problem. So some of the branches use, let's say, OSPF, some of them use EIGRP, some of them use, for example, RIP, and I'm going to configure these in VRFs, and I'm going to show you how we can configure them. Now, in our network, I have already enabled OSPF, and I'm going to, enable MPLS. One thing that is important in my network is for each one of these routers, I have configured the loopback interface. The loopback interface has a /24 address, but something that is important is to make sure that this is going to be advertised as 24-bit address, because OSPF by default advertises loopback interfaces as network loopback, and they are advertised as 32 bits, whatever mask you have set on, that's not going to be advertised. A 32-bit mask is going to be advertised. So one way to alleviate this and figure out and fix the problem is to make sure that the network, the OSPF network for these loopback interfaces is not loopback, but something like point-to-point. And I have done this, and I'm going to show you the basic configuration that I have on one of the routers, for example, PE1. So if I just go to provider edge 1 and show run interface loopback 0, you can see that I have added IP-OSPF network point-to-point, and this way they are not going to be a loopback interface. They are going to be just a network which are connected to these routers. Okay, so let's start with the basic MPLS configuration. One thing that's important in all of these configuration is to make sure that IPsec is enabled, and MPLS IP is going to be enabled here. Now, because we have OSPF, we can just configure all the OSPF interfaces that we have here as MPLS. And for this, I can just go to router OSPF configuration, and I can just type MPLS LDP autoconfig. And instead of going to each interface and type MPLS IP, I can just type MPLS LDP autoconfig here, and that's going to do the trick that we want. I'm going to do this on all routers. So let's open a notepad here. And by opening the notepad, I'm going to write these. So I just go to, let me zoom a little bit so that you can see better. Go to configuration mode. I'm going to go to global configuration mode and enable IPsec, also MPLS IP. And of course, I can have some configuration for LDP. Like I said, I'm not going to go deep into that. And I go to router OSPF1 process, and then MPLS LDP autoconfig, and then and save everything. This is what I'm going to have. So let's go to PE2 and do this. No problem. On router 3, of course. On router 4, router 5, and router 6. These are the routers that I have in my network, and after some time you see that LDP neighbors are up. So this is the first part. What about the next thing that we are going to do? The next thing that we are going to do is to make sure that PE1 and PE2 are neighbors. So there is going to be an internal BGP neighborship here. So let's go to PE1, and here I'm going to create router BGP, let's say 123. This is our BGP router ID. I can have, of course, some router IDs such as 1111, and then I'm going to have the neighbors here. My neighbor is going to be, let's say I'm using, because this is internal BGP, so the loopback interface is going to be okay. So 2222, remote AS is going to be 123. And I need to say that the update source, of course, is loopback 0. This is my side of BGP configuration. For now, of course, let's go to router 2 and do the same thing here. So I just go to configuration mode, and I'm going to have router BGP 123, BGP router ID, of course, can be set, and I'm going to have this neighbor in remote AS 123 with an update source of loopback 0. And after some time I should see the neighborhood come up, and of course it did. You can see this neighbor is up and working. Now the next thing here is to configure VRFs. VRFs are essential parts, and what I'm going to do is to configure VRF C1 and C2 for company 1 and company 2. And I'm going to use the route target and route distinguisher of 11 for C1 and 12 for C2, or maybe 1 for C1 and 2 for C2. That is company 1 and company 2 that I have. Again, every configuration that I have goes on PE1 and PE2. So let's do that. Let's go to PE1 and start the configuration. I need to clean here. This is very nice feature of Secure CRT that with just pressing one command, one key, you can clear the screen. So I'm going to create a VRF, and using VRF definition is better than IPVRF. Like I said, this is a newer version. So I'm going to define VRF C1. So RD is going to be 1, 1. Route target for both. Even if you do not type both, that's going to be enabled. 1, 1. Address family IPv4 for now. And exit address family. Also, I need to configure VRF definition C2. So let's do that. VRF definition C2. RD is going to be 2, 2. Route target for both is going to be 2, 2. Address family IPv4 unicast is going to be enabled. So this is our configuration here. Now I need to go for the interfaces and connect, assign those interfaces to these VRFs. So first of all, let's see what we have here. Our CDP neighbors are here, so I can easily understand which company is connected to my Ethernet 00, which company is connected to my Ethernet 03. So first of all, show running config of interface Ethernet 00, because I just want to have this IP address here. And I just go to interface Ethernet 00, and I'm going to say VRF forwarding is going to be C1, because this one is connected to C1. And you can see that the IP address is removed, and I'm going to add the IP address one more time, and everything is going to be okay. Now let's see the connectivity. If I ping, and because this interface belongs to a VRF, I need to say ping VRF C1 172.16.11.101. You can see that the ping is successful. Okay, the same thing should be done for Ethernet 03. So show run interface Ethernet 0/3, and interface Ethernet 0/3 belongs to VRF C2. And now this is the IP address that I have, and again I can check it to make sure that ping works just fine. 172.16.21.102, I believe. Or we just forgot to type VRF C2. And if the IP address is correct, the ping is going to be correct. So far, so good. Now, the next thing that I need to have is a kind of a connection with the routing protocols here, and I'm going to receive the routes that they are advertising, because I'm going to send these routes to the other branch on the other side. So let's do this in the second part of the course. In previous video, I created the VRFs and assigned the interfaces to VRFs. Now, you can assign interface or sub-interface. Most of the time that is a sub-interface, but here we are using physical interfaces. There is no difference between sub-interface and physical interfaces in this case. So what I'm going to do is to go to branches like C1 and C2 branch 1s, and I'm going to see the routing protocol that they have, and I'm going to create an adjacency with them, whatever routing protocol they have. So let's see what is on C1 branch 1. So if I just go to C1 1 and show IP protocol, you can see that this is using RIP. So what I'm going to do is to create a RIP routing protocol on P1, and then create kind of an adjacency with this so that I can receive the networks that this router is advertising. So let's go to P1, exit here. If I just type router RIP and hit enter, version 2 no auto summary. These are everything that I by default type here. Now you can see that here what I have is address family, and this one is important because we are right now working in VRF, so I need to go and configure address families here. So first of all, I just type address family. As you can see, we have IPv4, and then it asks for the VRF, or you can just type unicast and after that VRF, and the VRF that we are using here is C1. Now every command that you have in normal RIP you have under address family as well. So what I'm going to do is to type again version, do I have version here? Yes, version 2, no auto summary here, and then I'm going to assign the network that I have here. Network is 172.16.0.0. Why not complete network? Because this is RIP, and RIP only has classful definition of the networks. Now that I have this, let's see if I have received the networks from CE1. So I just type show IP route, and specifically the VRF that we are using is C1, and you can see that I have received every network that C11 is advertising. I'm doing the same thing for C12, which is branch 1 of company 2. Let's see what kind of a protocol they use. So you see that RIP is very simple. Let's see, show the running configuration of section router RIP here. This is the configuration that we have had for company 1. So C21, sorry, company 2, branch 1. I'm going to show IP protocol here. It says that they are using OSPF. We have configured OSPF for VPN before, so there is no problem. I believe that you can easily configure that. You can pause the video and do it as an exercise, or you can just watch me do this and then replicate it on your topology. So I'm going to exit here and exit here and type router OSPF. You remember that for router OSPF I have a process number because I already have used process number 1 for internal OSPF configuration here. I'm going to go with process number 2, and then it says what VRF you are configuring this for, and VRF is C2 for company 2. Like I said, this is case sensitive. Make sure that if it is uppercase you are typing uppercase, otherwise the case should be anyway respected here. So I can have a router ID here, but let's not configure router ID, doesn't matter as a matter of fact. So what I'm going to do is to type the network here, and the network that I have is, let me see, 172.16.22, I believe, 1. And it is configured in area 0, I believe, and after some time I should see an adjacency created here. So let's wait for that. If I have not mistaken the IP address, let's see, show IP interface brief. It says that 172.16.21, sorry. So the network is wrong, so I should remove this network and make it 21. Because this is branch 1 of company 2. Now you see the neighborhood here, which means that if I show IP route for VRF C2, I should see all the routes that they are advertising, which 21, 21, 21, 21 is one of them. Okay, now the last part is going to be configuring BGP and redistribution. But I'm going to do that after I have configured P2. So let's go to PE2 and do the same thing here. I'm going to save everything on P1. And for some reason I just typed WR 2 times, I don't know why. And let's go to PE2. Okay, on PE2, again I need to configure the same VRFs here. So I'm going to create VRF definitions. C1. RD is going to be 1, 1. Like I said, RD is locally significant, but route target, of course, is not. locally significant. You need to make sure that whatever you are advertising there, you are receiving here. So 2 for both of them. So address family IPv4 should be enabled on this. So another VRF definition which I'm going to create is C2. RD is going to be 2.2. Route target, both, is going to be 2.2. Address family IPv4 is going to be enabled for this. Now let's go for the interfaces. Show CDP neighbor here. Of course, I'm typing show CDP neighbor because every device that I have is CDP enabled. Most of the time, for security reason, you might disable CDP. That's okay. You can just check your diagram and see which interface connects to which router. But here, for the sake of simplicity, I never disable CDP. And I have seen in the actual exams, for lab exams of CCIE, of course, CDP is enabled most of the time, and you can easily figure out what are the other routers or devices connected to your device which you are working on. So here I know that C12 is connected to Ethernet 00, so company 1 Ethernet 00. Show run interface Ethernet 00, and then go to interface Ethernet 00 and say VRF forwarding is going to be C1. And then the address is going to be enabled for that. The same thing for interface Ethernet 0/3, which connects to some company 2. Oh my god. To show running interface. Also, interface Ethernet 0/3 is going to go for VRF forwarding C2, and now the IP address on that. Now the next step is configuring the routing protocols. Let's go to C21 and C22. Or C12 and C22. C12 show IP protocol says that this is using EIGRP 12. So I'm going to configure EIGRP 12 on PE2. So I say router, exit first, router EIGRP 12, and hit enter. And let's see what we have here. Again, we have address family under EIGRP. So I just type address family IPv4 unicast VRF C1. And then every configuration that we have under normal EIGRP, we have under VRF EIGRP as well. So again, no auto summary. And I'm going to have network. What is the network that we have here? For this is the network 0000, and after some time I should see an adjacency created between this and C12. Let's see what we have here. C12 says 192.168.12. P2 says 192.168.12. And I have not seen the neighborship for some reason. I'm going to see why. So the first troubleshooting is going to be a simple ping. C12 has this IP address here. So if I just go to here, VRF C2, the ping is not working. Maybe I have done a mistake when configuring the VRF. Let's see. To show run interface Ethernet 0/3. VRF forwarding is C2. No, there is no problem in that. And the IP address is there. And VRF C2, of course, is configured to show VRF says that C2 is here, and it is enabled for IPv4, and it is on Ethernet 0/3. So there should be no problem unless there is, okay, the IP address is a problem, right? Okay, Now I can see that the IP address on Ethernet 0/3 is a problem. Ethernet 0/3. The IP address is 12. For some reason I have said, okay, so let's see what I have configured here incorrectly. Do show run interface Ethernet 0/0. This is the one connecting to C1. C22. Show IP protocol is using EIGRP22. So that is EIGRP22. C21 is using OSPF, which we already have configured, I believe. No, or maybe not. So EIGRP22 should be there. So let's see. See here. No EIGRP12. Show run. Section rather EIGRP says we don't have it. Now configure it correctly. Rather EIGRP22. Address family IPv4 unicast, and VRF of course is going to be C2. Now that I have this, I'm going to configure this network here. And network is. Okay, now that I have configured this, I need to make sure that this is working just fine. So first of all, do show VRF is going to tell us that C1 is connected to Ethernet 0/0. Very nice. C2 is connected to Ethernet 0/3. And if I show CDP neighbor, this is correct. C2 is connected to this. Now let's see if I have the right configuration. This is the IP address I have here. On C22 I have 192.168.22.202. Let's see if I can ping it. So if I just ping VRF C2, and that's going to be 192.168.22.202, I should see that the ping is successful, which is successful. So the VRF configuration has no problem. So for the running configuration for section rather EIGRP is like this. Something that I need to assign it is the address family does not have an autonomous system. So you might say that autonomous system is already assigned to the global router EIGRP process, but this is not enough. So I need to add to this. You see that if I just go to here and press question mark, you can see that there is something like an autonomous system 22, and I hit enter, and after some time you see that the neighborship is there. So if I just show IP route for VRF C2, we have this, and for VRF C1, of course I guess I haven't configured C12. So C12 is the second part. Let's do this. And show IP protocol says that I have on C12 I have EIGRP as well, so I need to configure EIGRP as well. So let's go and do this on PE2. So the same thing as we had here. Going to exit, and type rather EIGRP12. No auto summary, of course. It is by default there, but I just type it. And then I have address family IPv4 unicast. VRF is C1. Like I said, autonomous system should be applied here as well. And then I'm going to have the network configured. What is the network on C12? That is, let me see, what is the network? 192.168.12.2. 0.0.0.0, and hit enter, and I should see the adjacency after some time. Now if I just check the IP route for VRF C1, you can see everything here. So what is the next step? we need to make sure that the routes from first branch gets to the second branch and they have connectivity, which I'm going to do it in the next session. So far, I have created VRFs on PE1 and PE2. I assigned the interfaces to these VRFs. Also, I showed you how you can configure different protocols for those VRFs and populate the networks into their VRF tables, which is going to be the routing table, of course, in this case. Now, what I need to do is to make sure that each branch can reach to the other. So what I need to do is to redistribute the routes from branch 1 to branch 2 and vice versa for both these components. So how can I do that? What I need to do is to go to BGP configuration, redistribute the routing protocol that I have with my customer to that BGP, and then using a VPN tunnel send it to the other PE, and then from there redistribute it back to the routing protocol of customer. So that's going to be a little complicated, but when I configure that, you will see that and you will understand that everything is so simple if you think, a little out of the box. So let's go to PE1. First of all, what I need to do is to show you what protocols I have. Show IP protocol tells me that I have OSPF1. This is for my internal network. If I just go down, I can see that I have BGP. Again, this is for my internal network. Going down, I have RIP here. And I should have another OSPF, of course, which I do not see, or I cannot find it here, right? There should be an OSPF2 as well, but I do not really see that. So if I just go to here and type include, routing protocol. Yes, we have OSPF1, BGP, RIP, and for some reason it doesn't show us OSPF2, which we have it, of course, because if I show you the running configuration of section router, you can see that I have OSPF2 for this specific VRF. Okay, now let's do the redistribution in BGP and in these protocols. So I just go to router BGP, but before that, show run section router BGP. Of course, we have it here. We have our neighbor here. So router BGP 1, 2, 3. For each one of these, I need to create an address family and then redistributing that address family. So first of all, I go to address family, IPv4 unicast C1, address family VRF C1, of course. And under this VRF C1, what I need to do is to redistribute the routing protocol which belongs to C1. In this case, it is RIP. So I'm going to redistribute RIP. Nothing more than that. I don't really need more than that. Route map or metric, I'm not going to do anything. And I just hit enter. The same thing should be done for customer 2. So I just go to address family, IPv4 unicast VRF customer 2. Customer 2 is connected to us using, let me see what routing protocol is, OSPF, process number 2. So I'm going to redistribute OSPF2, and again, nothing more than that. I can, of course, match, or I can use VRF, but we already are under VRF, so nothing more than that. Now, one thing that is important is to make sure that PE2 has a tunnel, a VPN tunnel connected to PE1, and it is enabled for sending the communities, extended communities in this case, because we are sending the routes using extra labels. So what I need to do is to type address family VPN v4 unicast, and under this I'm going to enable the network neighbor. So neighbor 2222 is going to be activated. Also, you need to make sure that neighbor 2222 has sent community, especially extended. Most of the routers, of course, do this by default, but here I just want to make sure that extended is done. So far, let's check the running config for section router BGP to see what I have done. You can see that I have configured address family and redistribution. Also here, address family and redistribution. The other thing that I have done is enable the other neighbor for VPN v4. The same thing should be done on the other side. But before that, let's do the redistribution in other routing protocols. So I have router RIP here, and router RIP is for C1. So I'm going to go to router RIP, go to VRF C1, and I'm going to redistribute BGP 123, and I'm going to assign a metric of, let's say, 2 here. This is a redistribution for router RIP. And the next one is going to be the OSPF, which I have for C2. So I just go and find the OSPF configuration here, router OSPF C2. Here we are going to have redistribute BGP 123, and I'm going to have all the subnets as well, and that's it. This is the first part that I have done, and let's save the configuration. I'm going to do the same thing on the other side on PE2. So let's go to PE2 and let's see what we have here. So again, show run section router, and hit enter, and do the same thing here. So let's go to BGP router BGP 123. I'm going to have address family IPv4 unicast VRF C1. For C1, the protocol that we had is here. Let me find the router EIGRP is for C1, right? So I just go to here and type redistribute EIGRP. What was that? EIGRP 12, I believe. C1 is 12. Also for C2, I have EIGRP, but it is 22. Now address family VPN v4 unicast is going to enable the other side. So I'm going to have neighbor 1111 activate. Also send community extended. Okay, this part is done. Let's go to EIGRP processes and redistribute back. So I'm going to go to router EIGRP 12, and under this address family, I'm going to redistribute BGP 123. The metric is going to be something arbitrary, it doesn't really matter what. And for the other one, address family what is this? Okay, rather EIGRP 22. Yep. That was haphazard. So that's going to be better to just copy and paste. So I'm going to have redistribute BGP 123 with an arbitrary metric. So it should be done. Everything should be done so far. And I'm going to save everything. Now that I have done this, I need to go for verification, and I'm going to do this in next part of the course.